Hi, I am Neeta Sharma from Brain League Learning. In this video, we will build a strong visual understanding of molarity and molality, see the key differences, work through examples, and learn when to use which. Let us start with precise definitions. Molarity, pronounced M, is moles of solute per liter of solution. Molality, pronounced M, is moles of solute per kilogram of solvent. We will visualize the denominators clearly: volume of the whole solution for molarity and mass of just the solvent for molality. Key differences. Number 1, the denominator, molarity, uses volume of the solution, while molality uses mass of the solvent. Number 2, temperature dependence. Volume changes with temperature, but mass does not. Number 3, typical use. Molarity is common in solution stoichiometry. Molality is preferred for colligative properties like boiling point elevation and freezing point depression. Example 1, molarity. What is the molarity? When 0.50 moles of sodium chloride are dissolved to make 0.250 liters of solution. We start with the definition. M equals moles divided by liters of solution, then substitute the numbers and compute 2.00 m. Example 2, molality. What is the molality? When 0.50 moles of sodium chloride are dissolved in 0.200 kilograms of water. We use the definition. M equals moles divided by kilograms of solvent, substitute, and get 2.50 m. When to use which? Use molarity when measuring volumes is convenient, for example with volumetric flasks in labs, and when doing solution stoichiometry. Use molality when temperature changes matter, such as boiling point elevation and freezing point depression, or when mass measurements are more precise than volume. Quick recap. Molarity is moles per liter of solution and can change with temperature. Molality is moles per kilogram of solvent and is temperature independent. Choose the one that matches your measurement and the property you are analyzing. Thank you for learning with Brain League Learning.